In this video, I will explain one of the most fundamental and essential building blocks in Beacon Tower, which is our use of asset models. In short, we use asset models in two ways. The first way we use asset models in Beacon Tower is to describe one-to-one the physical assets that are sending data to Beacon Tower, because we of course need to collect and contextualize the data that we are receiving. In order to collect and contextualize the data from the physical assets, we create one-to-one asset models that corresponds exactly to the physical assets. In Beacon Tower, we only have to create a one-to-one asset model for each different type of physical asset. If we then, in the physical world, have numerous assets of the same type, we only have to create an instance of the one-to-one asset model in Beacon Tower that corresponds to the physical asset type. That means it is very easy to automate the provisioning and collection of data from hundreds or even thousands of physical assets. These assets might be devices, machines or sensors connected directly to the cloud, or different types of gateways supplying data from numerous physical assets. The way we define asset models in Beacon Tower is by making use of the open source data modeling language called DTDL, which is short for Digital Twin Definition Language, and it is created by Microsoft. So another way of seeing our use of one-to-one asset models is to see it as a sort of digital shadow, which means that we in Beacon Tower define the actual telemetry signals, tag names that are configured on the physical asset to be exposed to Beacon Tower. And we also define which properties and commands that are exposed and supported in the asset model used in Beacon Tower. Now we just need to create instances of the asset models to create digital shadows of the physical assets. Now to the second way of how we use asset models in Beacon Tower. Because mirroring the physical assets in the cloud is often interesting in itself, but it gets way more interesting to add layers of business, operational or organizational interests. So in Beacon Tower, we can create asset models that are solely receiving data from other asset models, and thereby not directly from the physical assets. Let's call these layers for business models, since they consist of asset models that are mimicking the relevant business or operational structure. One important thing to notice is that our asset models are designed to perform calculations and transformations on the data signals, which means that we in our business models can now interpret the raw data signals that we receive through the one-to-one asset models and transform them into insights and predictions of the future. And we can even add external data signals in the business models, so that we, for instance, include in our calculations energy prices or weather forecasts, which means that we can now not only track the past through digital shadows and control the present, we can actually also now start to predict the future. Let's take a short view of how it's done in Beacon Tower. In this view, we see the auto-populated asset view in Beacon Tower. By auto-populated, we mean that it is a view that is generated automatically based on the asset model, which defines which telemetry signals, properties and commands that we want to expose in the Beacon Tower cloud. So what we're seeing here is an actual instance of the asset model. And this instance is handling the data streams from the actual physical asset. In this example, a car charger, number 226, even with an external battery. I can also click on one of the graph icons in order to zoom in on that particular telemetry. Now we're able to interactively and visually analyze the time series data from this telemetry signal. And we can slice the data in numerous ways and even compare it with other assets. But we will limit the scope of this video to asset models, and therefore we will not delve further into this in this video. So back to the auto-generated asset model view. We can also see that this car charger is part of a larger structure. You can see it over here. That is consisting of charging stations. We have numerous charging stations here. and different customers. So we have 1, 2, 3, 4 different customers with all sorts of different charging stations. This is part of our node tree capability, and it's not covered in this video thoroughly. We will just briefly touch upon the capability of attaching dashboard models to asset models. And let me elaborate by switching the tab in the asset view. Now we see a dashboard that is constructed to show relevant data for the car charger asset model. That means that this dashboard is auto-populated with data from the underlying physical asset. This is just a simple example of how we can configure dashboards to visualize the most important information of a single asset. For the purpose of illustrating the flexibility of Beacon Tower and the power of asset models, let's just briefly visit the charging station entity. Here we can see an example of how the underlying assets are automatically and dynamically consolidated, but also how we can calculate values that are based on numerous underlying assets. In this example, the current utilization. But we can also see in this example how we are able to integrate external data sources. For instance, the Nord Pool energy spot prices. Further, we also show in this simple example that we can integrate a machine learning algorithm that forecasts the future utilization of the whole charging station. So this is just an appetizer of how the underlying asset models can be used in a business and operational context. Now let's delve into how we can define the concrete asset models. For that we need to go into the administrator menu and click on models. Here we have a list of the available asset models in this Beacon Tower instance. Now it's a bit too time consuming to go through the actual process of creating an asset model from scratch. Therefore, let's just use an existing asset model as example. Let's delve into the car charger asset model. So what we can see here is an overview of how we have chosen to map the signals that are streamed from our car charger to our endpoint in the Beacon Tower Cloud. We see that our source signal names are listed here. And we see in this column how we map them into more comprehensible names and how we enrich them with metadata. For instance, we see the semantic type, we see the SI unit and the corresponding data type. This is actually the first basic data normalization. In Beacon Tower, we can choose to create these asset models in our web-based user interface. Or we can automate the creation of the models via scripting so that the underlying DTDL models are generated by scripts. Also, we can in Beacon Tower instantiate the actual asset instances in our web-based interface. This can, however, also be auto-generated if we wish to. That means that we can effectively connect to hundreds and thousands of devices in an automated and effective way. If we now click on Properties, we can in this simple example see the properties that are sent to the Beacon Tower Cloud, and we can also see that we in this example have write privileges to the property in question. We can also see that we in this example support commands. This means that we in this case can invoke commands and turn the car charger on or off. Of course, this is something that should be carefully considered, but the ability to, for instance, reboot devices are often needed. So what we have seen now is a simple example of how to work with asset models. We have also been touching briefly upon other needed capabilities of Beacon Tower, which will be covered in other videos, such as organizing of assets into node trees, integration to external data sources, rules and alarms on all assets and on all levels in the tree structure, dashboard models, access privileges, and how to use all these data models in external applications. All these capabilities are needed to build a powerful and modern data platform solution. This being said, these were the closing remarks and all for now for this video. And please remember, don't hesitate to reach out if you have any questions.